Okay, with question 19a, we were asked if nickel chloride is soluble or not, and it is. Chlorides are all soluble. According to our solubility rules, these are soluble ionic compounds. If it's got a chloride, the exceptions would be compounds of silver, mercury, and lead. And so nickel is not one of the exceptions, so it's soluble. With B, silver sulfide is insoluble, again because of our solubility rules. Here we've got insoluble compounds. Sulfides are insoluble with a few exceptions, and silver is not one of the exceptions. So we know that silver sulfide is insoluble. With number 20a, nickel hydroxide, that is insoluble. Again, looking at our solubility rules, the insoluble compounds are hydroxides. There's a few exceptions, but not nickel. So nickel hydroxide is insoluble. B, you've got lead 2 bromide, and that is insoluble. The reason is because, well, most bromides are soluble. However, lead is one of the exceptions. So lead bromide is insoluble. Well, number 21c. We are asked to see if a precipitation reaction happens, and if it does, to write the equation. So we know that a double replacement reaction, iron and lead swap places, they swap partners. So we would have lead sulfate, and we would have iron to nitrate. And I know that all nitrates are soluble. Okay, so all nitrates are soluble, so we would expect this to be AQ. And lead sulfate, we look at our solubility rules, and sulfates are soluble except for lead. And so therefore, this is a solid. It is insoluble. Now, if both of these were AQ, if they were both soluble, this reaction would not happen. The only time a double replacement reaction would happen is if it forms a precipitate, or if it forms a gas or something. You can't have AQ, 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 AQ. It can't be just aqueous all over, otherwise the reaction does not even occur. Okay, in 22a, we have to decide if a precipitate is going to form or not. And I know that Na and Ni are going to switch places. Na will bond with NO3, and that is soluble. We know that all nitrates are soluble. But nickel and hydroxide, now are again consulting our solubility rules, hydroxides are insoluble with a few exceptions. And nickel is not one of the exceptions. So nickel hydroxide is going to be our precipitate. So NiOH2, that's a solid, and NaNO3. Now balancing the equation, we put a 2 here and a 2 there, and that should take care of it. So that's the balanced equation. That's one that does occur because it makes a precipitate. Okay, with 23a, I wrote out the equation, and here it is. We've got aqueous and aqueous, and magnesium carbonate is the solid, the insoluble compound, and sodium sulfate is aqueous. Now, if something is aqueous on both sides, it is a spectator ion. So you're going to have Na and Na, SO4 and SO4. Those are going to be the spectator ions. So if we broke this into an ionic equation, we'd have 2 NAs and a CO3 and magnesium and sulfate. MgCO3 is not broken up into ions because it is a solid. And then we have 2 NAs and a sulfate. So you can see right there and right there, these guys are both spectators, sodium and sulfate. The rest, carbonate and magnesium, to make magnesium carbonate, they're actually doing something. Well, with 24A is very similar. You had to write a balanced net ionic equation for each of the reactions. So with A, you've got a chromium 1 sulfate. We know sulfate has a -2 charge. Chromium, each chromium is +1. So we're going to do a double replacement reaction. Chromium is going to bond with carbonate, and we would write it like this. Carbonate has a -2 charge, and so we need 2 of the chromiums, which was +1. And that is going to be our solid. It is insoluble. And then NH4, which is a +1 charge on our famous ion sheet, is going to bond with sulfate. And that is aqueous. So if we break up all of the aqueous substances, we've got 2 chromiums, a sulfate. Oh wait, let's balance this thing. I almost forgot. It is balanced. Okay. 2 NH4s, a carbonate, and this does not break up, so we've got Cr2CO3 as a solid, and we've got 2 NH4s and a sulfate. So the spectator ions would be NH4 and sulfate, and the balanced net ionic equation would be what's left. So 2 chromium ions plus a carbonate to give you Cr2CO3. And that's the balanced net ionic equation. I suppose we could add some AQs in there for fun. Okay, that's 24A. 24C, you've got iron 2 nitrate. Nitrate's -1, so iron must be +2 there. And we're going to have another double replacement reaction. Fe is going to bond with OH. And it's a solid. It's insoluble. Notice you need 2 OHs, because OH is -1. Fe was +2, as we saw right there. The other compound is K and NO3. Now balancing this, we're going to want to put a 2 there so that we have 2 NO3s on both sides. And a 2 right here, so we have 2 Ks on both sides and 2 OHs on both sides. Now if we break up everything that we can into ions, notice we've got 2 Ks and 2 OHs. Two Ks there and 2 NO3s. Spectators, K is the same on both sides, and nitrates are the same on both sides. So the net ionic equation is that right there. Okay, with 25, the answer has to be lead. It's the Pb+2. A precipitate forms with each of these solutions. That means PbBr, PbSO4, and PbOH. And those are all solids. They are insoluble. KBr, KSO4, K2SO4, and KOH are all soluble. A precipitate would not form in any of those circumstances. With barium, BaBr2, barium is soluble. So we see that because of the solubility rules, we've got the lead sulfate, lead bromide, and the lead hydroxide. Those are all Here the hydroxides are insoluble. The hydroxide, lead hydroxide, is insoluble as well. So in that case, lead is the only one that would make a precipitate with these negative ions. Now with number 27, it says here you've got an unlabeled bottle and you know it has one of these three substances in it. And a friend says you should test a portion of the solution with barium nitrate. Well, if you test it with barium nitrate, the Ba would combine with the sulfate. So if it's aluminum sulfate, the barium sulfate would make a precipitate. Okay. If you treat it with NaCl, the Cl in the AgCl makes a precipitate as well, an insoluble substance. Both calcium nitrate and barium chloride are soluble. Sodium chloride, calcium chloride. So if the unknown substance was calcium chloride, it would not make a precipitate with sodium chloride or with barium nitrate. If the substance was silver nitrate, it would make a precipitate with sodium chloride. And if the substance was aluminum sulfate, it would make a precipitate when you added a few drops of barium nitrate. Okay, with 38, here are the answers. This is a strong electrolyte because it's a strong acid. Anything that starts with an H and is on your strong acid list is a strong electrolyte. Same thing with nitric acid, strong electrolyte. C is ammonium chloride. That's a strong electrolyte because it is an ionic compound. It's got a famous ion. Ionic compounds will have a famous ion or a metal combined with a non-metal. So it's ionic and it's very soluble, so it is a strong electrolyte. This is a non-electrolyte because it's certainly not ionic. There's no famous ion there. There's no metal. It's a molecular compound. These are all made of non-metals, so it's a non-electrolyte because it's covalent. Here, this is a metal, cobalt, and sulfate. It's a strong electrolyte. And here, carbon, hydrogen, oxygen. It's a covalent compound. It is a non-electrolyte. All right, 39. I did this one ahead of time. We've got 39A. Here's your balanced equation. It's essentially a neutralization reaction. The H and the Ca swap. So you have H2O, or HOH, and calcium bromide. And crossing off spectators, all the AQ stuff gets crossed off. Calcium is a spectator, bromide is a spectator, and so all you have is H and OH and two H2Os. And you don't have to have these twos here. If you don't have those, that's okay. And finally, with C, we've got aluminum hydroxide reacting with nitric acid. It's another neutralization reaction. OH is a base, H is an acid. The H and the Al swap partners, and so aluminum nitrate and water. Again, all the AQs get to cancel out. So aluminum is aqueous over here, but it's not aqueous here. We've got solid aluminum hydroxide. NO3 is aqueous, and it's aqueous over here. So NO3 is the only spectator on here. We write out aluminum hydroxide because it was a solid to start with. We've got 3 hydrogen ions. The 3 NO3s got canceled out. 3 waters continue, and you still have aluminum because aluminum did not get canceled out. You've got aqueous on this side, but it was a solid over here. So that is your net ionic equation right there.